Alright, so here are my notes on using function rules to graph. The way this is going to work today is we're going to start just like we did yesterday by me showing you an old state test question. So this one says Eric is assigned to graph the line of this equation. We learned that was called a function rule yesterday. Use Erica's equation to complete the table below. How is this table different than yesterday's? So yesterday we started off with an old state test question just like this. But yesterday's, this table had some y values. You guys see how today it doesn't have any y values. So we're going to use those skills that we did yesterday and use them a little bit more. So I can show you how to make a line. So I can show you how my little grapher machine right here works. So everyone get what we're doing. We're going to figure out how this thing actually graphs this line for me. So our goal or our learning target is I can use function rules to find missing values on domain range tables. And I'm eventually going to make a line with that. Now, last time we were here, we found solutions for these function rules. Today, we're going to graph those solutions and make a line. All right? So our goal today is we're going to make a line. So to help us with this, we're going to make our own table. Because if I have a table, I can graph a line. That's what I did in the beginning of this chapter. It's going to look a little bit different than the table above, though. So let's go on to the next page, and I'll show you how to make a table for this. Because once we have a table for this, we can easily graph that table and make a line down here. So first off, my table is going to have 3 columns. My first column is going to have x, and you're going to make the same table every single time. My next column is going to have the function rule, which for this one is 2x plus 1. Now some teachers write equals y in their table. I like to give y its own column. So mine actually has 3 columns. The hard part for you guys to begin with is what x's to use. So I need to figure out what x's to put right here, because as soon as I have the x's, the rest of this is actually going to be pretty easy. My tip is to look at this line and see what x's they give you in your domain. They give us from -6 to 6. So what I'm going to do is I'm going to pick some easy numbers in there to help me make a pattern. The ones that I'm going to pick, though, are in my eyes the easiest. 0, 1, and 2. So now that I have those, I'm going to take those numbers and I'm going to plug it into this equation 3 separate times to create a pattern. So I'm going to go just like this, just like I did yesterday, and do it all 3 times first, because then I'm used to writing it by the 3rd time. Now that I have that, I'm going to take this 0, 1, and 2 and plug it in. And now when I do each answer here, or when I get each answer, I can graph them. So this first one is 2 times 0, which is 0, plus 1, which is just 1. So my first coordinate that I can graph has an x of 0 and a y of 1. So 0, 1 is going to be my first point. My next point, 2 times 1 is 2, plus 1 is 3. So 1, 3 is my next coordinate. And last but not least is 2 times 2, which is 4, plus another one, which is 5. So 2, 5 is my last coordinate. It is not enough to just stop right there, though. We need to put a line on this. And the reason that I need to put a line on it is because these are not the only numbers I could have used. I could have used any numbers that I wanted. Now, not all of them are going to show up on this graph, but I could have used any numbers that I wanted. And in fact, when I put this equation into my GeoGebra software program right here, it gave us those 3 answers. It gave us 0, 1 like we got, 1, 3 like we got, and 2, 5 like we got. But it also gave me all the rest of these answers as well. It gave me 3, 7, and 4, 9, and 5, 11. And that's because this actually has infinitely many solutions. So in order to show that, I'm going to put a line down here. And I'm going to make sure that it connects all three of my points. And because I could go forever in both directions, like when I looked at my GeoGebra software right there, it actually did go forever in this direction. I'm going to keep trying to go. It's not letting me, though. There we go. See how it keeps going on forever and ever? So because of that, what I'm going to do is I'm going to put arrows on both sides. So you need to have a line and arrows after you graph your little bit of a pattern. Now, one thing I wanted to point out before we move on is if I used a different coordinate, such as -1, let's see what would have happened up in my table. So up in my table, if I used -1, and I filled it out just like I did before, 2 parentheses plus 1, and I put in -1, what is 2 times -1? -2 plus 1 is -1. If I look down at my line right now, see how it says -1, -1? What do you think would happen if I were to plug in -2 into that equation? Well, hopefully you saw that it's just what's right there. It would be -3. All right, so hopefully all of that makes sense for you so you can see how we graphed that. It really isn't that bad. Now, before we move on to the next example, I said this table is basically the same table as the one from the state test problem on the last page. What is different about my table, this guy, and their table? Well, theirs doesn't have the work right in the middle. That's really the only difference. If you wanted to add it at the end, like that, and then do what we have been doing, it would be the same exact table. The only difference is that theirs, they actually give you the x values to use. Like they give you -1, 1, and 3. So if you were to go off on the side of your paper and make this table, you'd have to use these x values. All right? So they just didn't have the work column. So it has the work column. All right, so let's take a look at the next example. This is the one that we looked at yesterday. I want to just go over this one again because you guys know what should show up right here. But why don't we make the table that I showed you today? So what happened in the first column of our table? It was x. How about in the second column of our table for this problem? It's going to be 3x minus 2. And in the last column for this problem is y. All right. We definitely need to fill out 2. But why don't we pick a couple other ones just so you can see that I'm not BSing you. All right, so why don't we do, I don't know, -1, 0, and 2. So remember, the first thing I want you to do each time is rewrite your equation, but without the x. So 3 parentheses minus 2, 3 parentheses minus 2. And inside of each one of these, you're going to be placing the -1, the 0, and the 2. So now let's do the math out. 3 times -1 is -3. Minus 2 more is -5. Which, if I look back up at my table, was I supposed to get -1, -5? I was. This next one says 3 times 0, which is 0. Minus 2 is -2. 0, -2, just like they said. So hopefully you can see that I'm not BSing you by now. And the last one is 3 times 2, which is 6, minus 2, which is 4. 2, 4. If I draw my line to connect these 3, I am done. Remember, you need a line to show that these are not the only 3 answers to this. This is just the 3 that helped us make our pattern. And remember, to show that it goes on forever, you need arrows. So would you please replicate what we just did twice down here on number 1? When you do this one, though, make sure that you use 3 good inputs or 3 good x values in our domain that are on this graph. All right, so please take a second, pause the video, try it, and when you're confident that you're done, unpause it and check. All right, so let's use our table. X, -2x plus 2, just like up above, and y. hopefully we all used similar x values, maybe 1, 2, and 3, or 0, 1, and 2 is what I'm going to do. So inside of here, I'm going to put -2 parentheses plus 2, -2 parentheses plus 2, and last but not least, and I'm going to plug in 0, 1, and 2. In this one, 0 plus 2 is 2, so 0, 2. In this one, -2 plus 2 is 0, so 1, 0. And last but not least, -4 plus 2 is -2. So 2, -2. So to make a pattern, if you draw this and the pattern does not come out nice, like one of these points is over here, obviously you need to check one of them. All right, but I'm going to draw a line on this to show that these are not the only 3. And I'm going to put arrows on the end to show that it goes on in each direction. All right, before we move on to the back, I just want to ask you, what is the slope of this line? I see I'm going down 2 and over 1. Huh. And how about up here? What is the slope of this line between this point and this point? Up 1, 2, 3, and over 1. I wonder if that's got anything to do with that. But anyways, let's move on to the back right here. The big thing that I need to tell you about this is you can only do this if it says y equals. If it says something other than y equals, that's going to be something that we tackle on a later notes. All right, so solutions with 2 variables have infinitely many answers. I think I meant to say equations with 2 variables right here have infinitely many solutions or infinitely many answers. What I mean by that is these 3 answers that we found for this table are not the only 3. Remember, we also found -1. Or if I wanted to, I could have looked at -2 or even -3 and found answers for that. So these 3 that we find are not the only ones. That's why we need to use a line. All right. The next one is we organize these solutions by putting them in a table. Because it's impossible to find all of the solutions, we need to find enough to make a line, just like we talked about up here. Your line needs to go all the way across the graph. And last but not least, remember to put arrows at the ends of your line. All right, guys, that's it. Thank you so much for watching.